All right, my half angle identities problem type 2. On your half angle identities problem type 2, you're just going to need the sheet with your half angle formulas, and so you'll want to keep those handy that we had before. Sine of u over 2 is plus or minus 1 minus the cosine of u over 2. For cosine, we have a plus in there. For tangent, we've got a bunch of different formulas. I'll usually just use that first, or not the first one, the one without the square root, the sine of u, and 1 plus cosine of u. So, hopping back over here. We are first of all going to do our reference triangle. It says that the tangent of theta is equal to negative 15/8 and is between 270 and 360. So that angle is going to be over here in quadrant 4. This is the opposite over the adjacent. My opposite side would be negative 15 since it's going down. My adjacent side is 8. I'm then going to use my Pythagorean theorem to figure out what my hypotenuse is. So negative 15 squared is 225. 8 squared is 64. So I get 289. Square root of 289 is 17. So my hypotenuse is 17. Now when I'm doing my half angles, I want to figure out what quadrant my half angle is in so I know if my cosine or my sine is going to be positive or negative. So here my half angle would be half of those between 135 and 180. So my half angles are going to be in quadrant 2. So using my half angle formula, for the cosine, my half angle formula, I'm in quadrant 2. My cosine is going to be negative. And I am going to use 1 plus the cosine over 2. My cosine, the adjacent over the hypotenuse, is 8/17. So I have 1 plus 8/17 over 2. I want to simplify that. Since I have that fraction, I'm going to multiply everything times 17. So I'm going to get 17. That cancels out, plus 8 over 34. So I get negative the square root of 25/34. Square root of 25 is 5, so I'm just going to have minus 5 over the square root of 34. You can rationalize the denominator on that if you want. They will also take the answer in this form. If you do rationalize the denominator, you would just multiply by the square root of 34. So I'd have negative 5 square root of 34 over 34. And that answer would also be a good answer. For tangent, on tangent you don't have to worry about the sign because the sign should come out right using your formula. For tangent you have 3 different formulas to choose from. I like to use the one with the sine of theta over 1 plus the cosine of theta. And so my sine, opposite over hypotenuse, negative 15/17. 1 plus my cosine, 8/17. And again, I'll get rid of those fractions by multiplying by 17. Cancel that out. I get negative 15 on top. Then I get 17 plus 8 on the bottom. So negative 15 over 25. I can reduce that fraction down because I can divide by 5. So negative 3 over 5 is going to be my answer in simplest form. Number 5, we are between 0 and pi over 2. So pi over 2 would be 180 over 2, 90 degrees. Between 0 and 90 would put us in quadrant 1. My sine which is my opposite over my hypotenuse, is going to be 3 and the square root of 13, if I can write square root of 13. And again, we've got to find our missing side, so if I use my Pythagorean theorem, 3 squared plus b squared equals the square root of 13 squared. So this would be 9, this would be 13. If I subtract my 9, 13 minus 9 is 4, square root of 4 is going to give me 2. So I've got my reference triangle. I want to do my half angles. Since this is between 0 and 90, I would be between 0 and 45. So I'm still going to be in quadrant 1. In quadrant 1, your cosine and your tangent both should be positive, because everything is positive in quadrant 1. So again, I'm just going to go back to my formula. So for my cosine, I'm going to do positive square root of 1 plus the cosine over 2. And so I'm going to have square root of 1 plus my cosine would be my adjacent over my hypotenuse, so 2 over the square root of 13 over 2. Lovely. I got to get rid of that fraction, so I'm going to multiply by the square root of 13. So I'm going to get the square root of 13, that cancels, plus 2 over 2 square root of 13. Can't do much else with that. I'm just going to put in that big, ugly, crazy looking answer. Then I'm going to do my tangent. For the tangent, I like the sine of theta over 1 plus the cosine of theta. You can use a different one of the formulas if you want. That's just the one I like to use. So my sine would be 3 over the square root of 13. 1 plus my cosine is 2 over the square root of 13. Again, I'm going to multiply by the square root of 13 so that I can get rid of those fractions within my fractions. And so on top I get 3. On the bottom I'm going to get the square root of 13 plus 2. And again, they're not going to worry about rationalizing the denominator or anything like that. So 3 over the square root of 13 plus 2 is just how I would leave it, and I wouldn't worry about multiplying by the conjugate to simplify it any further than that. So number 6 tells us that the cosecant of theta equals negative 13/5, and you're between 270 and 360. So I'm going to be in quadrant 4. My cosecant is my hypotenuse over my opposite. So my hypotenuse is always positive, it's going to be 13. My opposite is negative 5. And if I use my Pythagorean theorem, negative 5 squared plus b squared equals 13 squared. That's 25, that's 169. If I subtract my 25, I get 144. Square root of 144 is 12. That's going in the positive direction, so I've got my reference triangle drawn. Here I'm doing my half angle, so half of 270 would be 135, is less than theta, which is less than half of 360, which is 180, puts me in quadrant 2. In quadrant 2, my sine is going to end up being positive. My tangent, although I don't have to worry about, is going to end up being negative. So on my sine, I am using plus the square root of 1 minus the cosine over 2. So I'm going to have 1 minus my cosine is 12/13 over 2. I am going to multiply by my 13 to get rid of my fraction. So I am going to get the square root of 13 minus 12 over 26. 13 minus 12 would give me 1 over 26. The square root of 1 is 1. So I would have 1 over the square root of 26. Should take it that way, or if you rationalize the denominator, you're going to have the square root of 26 over 26 for your answer. Tangent. I'm going to smush tangent in here. I always end up doing that. Tangent of theta, we said, was the sine of theta over 1 plus the cosine of theta. So my sine is going to be negative 5/13. 1 plus my cosine, which is 12/13. And then again, I'm going to multiply by that 13 to get rid of the fractions. Cancels that out, cancels that out. On top, we just get the negative 5. On the bottom, we're going to get 13 plus 12, which is going to be 25. I'm going to go over here. So I have negative 5 over 25. And if I have negative 5 over 25, I can reduce it down. So negative 1/5 is going to be my answer for the tangent of theta. Actually, the tangent of theta over 2 when we solve that.